Good evening, everyone. So we will get started, and I'm going to record this lecture. That way, you can watch it later on if you couldn't attend today's meeting. So I wanted to go through this lecture, which is a follow-up to our first lecture when we talked about the definition of management information systems. And when we defined management information systems, we said it is a set of components that work together in order to transform data into information, right? The same thing for analytics or business analytics and data mining and machine learning, which are alternative names for data analytics. So you might hear about business intelligence, machine learning, data science, artificial intelligence. All of those kind of are used exchangeably with business analytics. So the definition of business analytics is very similar to the definition of management information systems, which refers to a set of components, which includes quantitative methods, information technology, programming languages, business policies and business processes, all of them, and people, that all of those components work together in order to transform data or raw facts into useful information that can be used for insightful decisions that can help businesses grow or profit or reduce costs, right, to any organization. So today, this is what we will go over, analytics. So I will ask that everyone to mute your computer until we open it for question and answers. So this is what we will do today. We'll go over data mining and machine learning, and then we'll do a quick demo on Orange. Although you have already had actually the chance to work on Orange through the videos that I posted, but I wanted kind of to emphasize it in this lecture. That way, if you have any questions, you can raise them, but also emphasizes what we really mean and when we use data analytics and machine learning. And then we will go over, open it up at the end kind of for project 7 and 8. So what is business analytics? So as I mentioned, it is a set of components that work together in order to transform data into useful information. But when we talk about business analytics, there are alternative words to it. So machine learning, artificial intelligence, business intelligence, data science, all of those actually, that's what they use them alternatively with business analytics. So in this class, as I said, you will need to include those skills that you have learned in this class in your resume and put them there under the technical skills. Business analytics is one of the skills. Data mining is one of the skills that we learn in this class, actually, especially in Project 7 and Project 8. You learn data analytics, which includes everything from SQL all the way to Excel, to machine learning, to data visualization, which is Tableau. So Tableau definitely needs to be there as a term under your technical skills. And then you can include business analytics, data mining, machine learning. Those are buzzwords because when employers are looking for a new hire, they scan. Actually, you will see how we will use texts to read for us, to make decisions for us. So they use machine learning to read your resume before they decide whether they are going to interview you or not. So if you have those keywords and the machine learning algorithm can pick them up, then you have a better chance for an interview, then you can prove yourself to them. And when we talk about business analytics, and the first thing that we need to distinguish and understand, which will save you 50% of the struggle, is to understand the difference between categorical variables and numeric variables. So from its name, categorical variable means that variable deals with categories. Those categories you know, can be gender. For example, we have the male category, the female category, right? Um, the color categories, right? We have yellow, white, red, and so on. So Diego, can you please mute your phone or your iPad? And then we have other categories might be your classification as a freshman, senior, sophomore, or junior, and so on, or a bachelor, master's. So those are kind of what we mean by categories, right? Smoker, non-smoker, that's a category, right? That's kind of one of the assignments that you are going to do. So that's what we mean by categories. It is something that is not numeric, it is categories. Zeros and ones, that's a category, binary category, right? And then the other type of data is numeric, which means it is continuous numbers, right? So it can include age, it can include salary, it can include height, weight, all of those, the values or a variable that has continuous numeric values, right? Whether it has integers or has fractions or not, it should not be a problem, as long as that number is continuous, right? So that's what is really important to understand, the difference between numeric versus categorical variables. You might have also seen when we dealt with Tableau, we had dimensions. The top, you might have seen the dimensions kind of the top category in the menu for the data, and then in the bottom, they call them measures. So the measures are numeric values on the bottom left side of Tableau. And then on the top left side of Tableau, they call them dimensions, which means categorical variables. And then the bottom side, the measures were numeric variables. And the numeric variables include sales, include profits, and so on, right? So again, it's very important that we distinguish between those. Numeric, which means continuous or integer, and then categorical variables can be ordinal or nominal. So what we mean by ordinal, just to make it simple, any categories that have order in them, implied in them. So order for ordinal, right? So if I say freshman, sophomore, junior, senior, so there is an order implied in these categories, right? And then when I talk about bachelor, master's, doctorate, so there is also what we call, there is an order implied in them, right? So that's what we mean by an ordinal categorical variable. On the other hand, there is a nominal categorical variable where there is no order implied in them. So for example, like male versus female, there is no order implied in them. Colors, yellow versus red versus, there is no order or something better than the other. So that's what we mean by nominal. State, for example, the state is nominal because there is no state better than other in terms of order, right, or importance. So this is what is really important. If we get this one, then you will be set actually with the rest of data analytics. So machine learning, Vanessa, can you please mute your computer, your computer, and then when we open it for question and answer, then you can open it. So one important concept when it comes to data mining is machine learning. So from its name, when we talk about machine learning, that means actually the machine is learning. What we really mean from its name, actually, the machine is learning from historical data, so that way it can predict in the future. And this is exactly what we are doing here. So let's say that I am a bank, you know, and I have collected data about customers, whether it is from social media, from their profiles, and whether they defaulted or did not default in a loan that I have given them as a bank, right? So I have all this data about them. I have about their gender, about their zip code, where they live, how many cars they have, how much income they have, how many children they have, you know, level of education. So I have so many variables about them, so many features about them, right? Many attributes, characteristics about them. So all those attributes, characteristics, we call them variables in data analytics, or we call them attributes, or we call them features, right? So I have all this data about those customers in the past, and I already know whether those people that I have data in the past defaulted or did not default in a loan that I gave them, right? So now what I will do, I will feed this data into the machine using machine learning algorithm. That algorithm will learn from the past data set that I just fed it, and it will learn the characteristics of those who defaulted. And it will learn also the characteristics of those who did not default in the loan from the past. So that way, when I have a new customer coming, I will plug in that customer's data into this algorithm. And then this algorithm or machine learning algorithm will tell me the probability of default, or this particular customer, whether this customer will default or not, with the probability scores from 1 to 100. So what is the probability? 80%. So in that case, as a bank, I can either raise the interest rate on this person, or I can just deny to give this person a loan. So this will save me as a bank a lot of money, because now I am avoiding risk, avoiding risky customers, right? Based on the machine learning algorithm that has learned from past data. So that's kind of the benefit of it. Another example or another benefit from machine learning that you can relate to you as a student. For example, here as a university, we have an alumni foundation. So we need to collect data, or we need to collect donations from alumni, so that way we can afford to give our students scholarships, right? So we have so many alumni. Let's say that we have almost, let's say, million, just hypothetically. And if we send mail to every one of those million alumni, that will cost us $1 million, right? If assuming that it is going to cost us $1 for the mail going and the mail coming back, you know, the stamps and paperwork and so on. So that's a $1 million, right? It's a lot of money, but not everybody from those million will actually return and give us a gift. So instead, what we can do is we can learn from historical data, those who we sent them mails in the past, and what were their characteristics for those who actually gave us a gift or give us money as donations, right? So based on that, the machine learning will learn. Now, if we have new alumni, they just graduated, we can actually plug that into our machine learning model, and then it will tell us the probability of that particular alumni, whether they will donate or not. So it is gonna save us, instead of sending 1 million or spending $1 million on that, we can send it only maybe to 10,000 who are going to maximize the donations that we receive, right? So now we are saving ourselves so much. Instead of 1 million, we are spending only 10,000, but we are maximizing the donations that we get. So you got the idea, the benefit to organizations of this machine learning and data analytics. So when we talk about machine learning, we have supervised learning versus unsupervised learning. So the supervised learning means that we have a target variable that we are trying to predict, whether it is classification or prediction. So we have something that we are really interested in knowing. So the target variable that we were interested in as a bank was default versus not default. I want to try to predict whether the customer will default or not default. So that was my target variable, right? So for the Alumni Foundation, also the target variable was donation, will donate versus not donate, right? So that's my target variable. But when I say unsupervised learning, that means I don't have a target variable. It's like a black box. You are interested in learning something about that data set. You are interested in letting the machine learning to tell you something about that data. any patterns, any trends, just to tell you something. So that's kind of the difference between supervised learning versus unsupervised learning. So supervised learning, when we have a single target variable that we want to predict. Unsupervised learning, we don't have a target variable. So core ideas in data mining is classifications and predictions. So when we talk about supervised learning, we have classification. So classification, from its name, class, we are trying to predict a class or a categorical variable, right? So the class can be male versus female, it can be smoker versus not smoker. So that's what we mean by classification. So we are trying to predict default versus not default, donate versus not donate, right? So those are what we mean by classification. When we talk about prediction here, we mean that our target variable is continuous, which can be sales. We are predicting sales, or trying to predict profitability. We are trying to predict age and so on, right? Or income. So that's what we mean here by prediction. Those two are for supervised learning, classification and prediction. The rest, association, data reduction, data exploration, visualization, those are what we mean unsupervised learning. We don't have something in mind that we are really interested in. We are just, it's like a black box. You are trying, please find something interesting for me, right? So now let's see what we, an example of classification. Again, classification is a categorical variable. It can be credit-worthy, not credit-worthy, fraud, not fraud, and so on. Prediction is continuous variable. But when we talk about unsupervised learning and association rules, so there is a story about association rules. So there is a super center or a supermarket in the Midwest region of the United States. They conducted a data mining using association rules in their data, in their database. And they found out that people or young professionals or young adults, whenever they go to that superstore or to that supermarket, they tend to buy beer and diapers at the same time. So that's what we mean by association rules. So people who bought diapers tend to buy beer, right? So that's kind of the association rules that they figured out by data mining, by trying just to find out if there is anything interesting. So they didn't have that in mind, but the machine learning figured that out for them. So then they investigated. They said, why do the diapers go with the beer? What is the relation? Those are like totally different products. One is kind of for, you know, consumption, like for eating or drinking. The other one is just a commodity product that is not for eating, right? So then they figured out that young adults, especially men, when before they had babies, they used to go to bars to drink. Now, since they have a baby, they can't go to the bar. So when they go and buy diaper, they remember that they wanted to go to the bar, but now they can't because they have the baby they need to take care of. They end up saying, I will get a beer as well and drink it at home instead of going to a bar. So this is a very interesting story illustrating the association rules, but also what is the practical implication of it? What should we take away from this? What is the benefit from this rule? So the benefit from this rule is the placement of the products in the store. So if you go to Walmart, so this story is not about Walmart, but just as an example, if you go to Walmart and you go, you figure out, actually I have a 15 months baby, and I know exactly where the diapers are located. So they're all the way back in the back, right? And then next, when you are going back, you know, out to the door, you will see the beer aisle also in the back to your left, right? Next to the, very close to the diapers aisle. But you got the idea. So the placement makes a difference, because you might go and buy a diaper, and then you will tend maybe to look to the left, and then you will see the beer, and you say, oh yeah, I remember, I need to get the beer. So now the placement of the products in the store increases as a result of the utilization of this association rule. So this is just an example. Another example can be in healthcare. For example, those patients who, let's say, contracted COVID-19. What are some of the diagnosis correlated to it? So those who have COVID-19, what else do they have? Is it correlated? Is it associated with high blood pressure? Is it associated with diabetes? Is it associated with obesity? So what are some of the other diagnoses that we can identify? That way we can prevent those symptoms, so to reduce the contraction or the severe effect of COVID-19. So just kind of as an example. So association rules, machine learning is very beneficial to our lives, not only in the business side, but also in healthcare. So data reduction here, sometimes we have so many variables. You know, those uh, credit scoring companies, they collect so much data about us. I would doubt that even our online behavior, actually our online behavior is also collected. So what website you have used, you have been to. So when you go and visit a certain website, they collect behavioral data about you, how long you have stayed in that website, what other websites you have watched, what other products you compared. So they collect all this data about you. So there are so many columns, so many rows, so many columns about you, so many variables about you that might go up to 100 variables. But which one of those variables is more important? So that's what we mean here by data reduction. One of it is to reduce the number of variables. Another part of it is to reduce the number of rows. So clustering can be one example of reducing the number of rows. uh, Principal components, and so on and so on. So those are some of the examples that I will not go deep into, but what is really important is the concept that we need to reduce that data. And then data visualization helps us kind of in identifying if there is an outlier or anomaly in our data set, and if there is a correlation between two continuous variables, for example, right? Uh, so the process of data mining, this is kind of IBM. They came up with this process, and we tried to do that in the video, that the practice video that you watched for data mining or for business analytics or data analytics. So we started by defining understanding the purpose. What is the purpose? We are trying to predict if in our data set, if that person who has respiratory issues is a smoker or not, for example. You know, the purpose is to predict whether that person is a smoker or not, just as an example. And then obtain that data, we have that data, then we can clean the data. So some of you might ask, what do we mean by cleaning the data? So the data, it depends on the software you are using. So for example, Orange doesn't require you to convert text data into numeric values, but Excel requires you to convert text data into numbers in order for data analysis to be run, right? So that's kind of part of the data cleaning, identifying missing values. So if there are missing values or in a row, you can either, if they are very few rows, then you can delete them. If you have very limited number of rows, then maybe you can replace those missing values with the mean or the average of that column, right? So that's what we mean, and you saw the example in the video. And then reduce the data. So this is what we mean by feature reduction. This is a feature also is provided in Orange, and I believe I covered that in the video, in the example. And then specify the task, whether it is classification, clustering, association rules, or prediction, right? So if it is classifications, then we know which technique or which algorithm we should use. So if it is classifications, that means our target variable is categorical. So in that case, the logistic regression will be used in order to predict a categorical variable or for classification. Linear regression only used when our target variable is continuous or numeric, right? So this is the important distinction. The other machine learning algorithms, most of the other algorithms, they don't, they work for either continuous variable or for categorical variable as a target variable, right? And then we do some tuning, and then we assess the results. So what is the accuracy rate if we are predicting continuous variable, or what is the classification accuracy, right? So the accuracy rate, or the, the, the average error mean of the average. So those are kind of some of the performance measures for our models. Then if we have a best model, then we deploy that model. We use it for predicting future data sets. So again, we need to make sure that we understand what is our target variable, whether it is numeric or categorical. Then we can decide which algorithms we need to use. So most machine learning or data mining processes or platforms, they recommend that we divide our data set into partitions. So the training partition is the data set, or the partition of the data set that is going to train our model. And then we have the validation partition, and we have the testing partition. So they recommend that we have 3 partitions. That means, let's say, 40, 40, 20. So from 40% of the data set is for training, 40% is for validation, and 20% for testing. So we do that just kind of to avoid if there is overfitting. Sometimes our models or the machine learning might overfit the data to make that data we predict and classify every single item with very close accuracy, right? So that's what we mean by overfitting the data. But the training partition might overfit the data. But if we have a validation partition or a testing partition, then we will know if our data is actually overfitting or not. So again, it is up to us. So for us, maybe we will just do maybe 60-40, 60 for training and 40 for testing, right? So we can do that either or will work for us. So now let's go with Orange. Orange is actually an open source, a GUI, graphical user interface software that a lot of people use. And it is based on Python and C++ programming language. And it is a great software that I really love to use it for teaching purposes, because a lot of organizations in our Masters of Science in Business Analytics, we use R and Python for teaching, which are script language. So you have to type the commands for your computer. On the other hand, in Orange, you just drag and drop. So it's a graphical user interface. It's much easier to understand and use. So it first was developed in 1997, and now it is widely used by so many scholars and data scientists. So it is open source, which means that it is free. You don't have to buy a license for it, and it is updated regularly. So it has, that's kind of the beauty of this software. It is open source, free, no programming is needed, and it has add-ons like the text mining that we will do actually for project 8. So this is kind of when we open Orange, this is what we get. So we can say new, but you get the idea. So those are the categories here in the left side. We start working with data, visualize data, model. So it's kind of a workflow for, and then we have text mining at the end, which is an add-in that I explain how to do that in the video. So we will work on this data set as an example for the sake of this demo. So there is an embedded data set in Orange called heart disease. So it has 303 rows or records or instances, and it has 13 attributes, means it has 13 variables. And it is also in a CSV format. And our target variable is a categorical variable, which is the narrowing diameter. So if the diameter of the blood vessels, if it is narrowing, then it is 1, coded as 1. If it is not narrowing, it is 0. Because if the artery is actually narrowing, as a diameter, that means you have heart disease, right? If it is not narrowing, then you don't have heart disease. So that's why we called it a heart disease, right? So we have several variables here. I will not explain all of them. Some of them, they are self-explanatory. And let's run. I will do the demo in a little bit, but this is what we see when we see the data set. We need to have the role to change, so to make sure that the role for all the predictors as feature and our target variable, we need to assign it as a target variable. So the diameter narrowing is 0 or 1, and we need to double click on that feature and make sure that it is target. So now let's go to orange. So this is my orange. I will go to data, and then I will go to file. So from the file, you can click on this, and then actually it will take you to the heart disease. I can also give you access to this data set as well in Excel. So this is the heart disease. This is the data set. As you can see here, the role, all of them are features, but I'm interested in to make sure that the diameter is my target variable. So I will double click on it, and then I will select it as target and say apply. So now I can close out of this. So now if I wanna see what this data looks like, right? I wanna see how it looks like. So I can bring this widget, just drag it and drop it and connect the file widget to the data table. Now it will show me all the variables and the values actually in my data set, right? So the target variable is always darkened in dark color. So that was one thing. So that's what we mean by uploading the file and then looking at it. Then you can do data reduction. I have seen that, I have shown you in the other video, but let's do exploratory, exploring this data set. So you can explore this data set maybe by looking at the distributions. So for example, this is the distribution, distribution of, let's say I want to see age and I want to see diameters. So you got the idea here, distribution. So those who have heart disease, so it seems to have their age is towards kind of in the 60s, right? A little bit older, tend to be a little bit older. Those who don't have, they tend to be kind of a little bit younger, right? So you got the idea here what we mean by visualization. So you can remove this guy from here. So now I want to take you through and a thing that we didn't cover in the videos there. So it is the sampling. So I will go back to the data, and I want to divide my data set into two partitions, the training versus the validation or testing partition. So I need to look for the data sampler widget. I will bring it here. Then I will connect it here. And then I will click on my data widget. For the data sampler. So I will make sure that it is selected as fixed proportion of data. So 60% is for my training, and the 40%, the rest, which is 40%, will be for testing. So I'll just say sample data and then close, right? So now what I will do is I will include variable. So since I have a categorical variable as my target variable, I can add some algorithms. So now I'll start modeling. So the different models that we have k to the nearest neighbor. So k to the nearest neighbors usually judges or looks at the 5, in this case, looks at the 5 neighbors around that particular row or that particular observation. And then based on that, it decides, the machine learning decides. And then we have decision tree or classification and cart and regression tree, they call it, right? And then random forest. just enough and then support vector. Then you have neural network. So neural network, as we said, it is used for self-driving cars. So all of that, and then we can actually evaluate. So I can connect my data sets to those algorithms. So I'm just putting all of them together, and I want to kind of compare which one is doing better, right? So test. So let's see. Remove. I'll just remove those guys here for now. So this one is not this guy. So I need to double click on this guy so that way I can have a test. So I can have the data sample to the data and then the remaining data for the test data. So I'll keep that one. So now I can. Arceli, can you please mute your phone, computer? Thank you. So now, as you can see here, this one is the decision tree. The classification accuracy rate is 78%. So that's good. Now I will add some more algorithms or models, and I will see which one performs best. Right? So I am testing. If you notice here, I am testing on the test data. Right? So because I don't want to test on the training data, because as I said, the training data might overfit, right? So you will notice that the numbers might differ from classification. So the training model or the training data, the classification accuracy is very high. So that's kind of exaggerated. 94%, almost 97% for random forest. But what is really interesting, what we really are interested in is in the testing data. So that the testing partition actually gives us a better idea for accuracy. So now when we compare those different algorithms or different models, machine learning algorithms or machine learning models, we can see that the classification accuracy is higher with neural network. So maybe we can add, let me add maybe logistic regression, because it's important to distinguish between logistic regression versus linear regression. So since we have a categorical variable as our target variable, so in this case, logistic regression will make better sense. So let's see what we can find logistic regression. I will also add it here. So now let's see, compare which one is doing. Actually, logistic regression is doing better than all of them. So in this case, what we will do is we will deploy or publish the logistic regression. We will end up using logistic regression because it is doing better than the rest of the models or the models. So we can just delete the other ones. And then we will keep logistic regression. All right, so now let's say that we have a new data. So this is all data, historical data. Now let's say that we have new data. So the new data, I will drag and drop a file. This is what you did actually for the homework as well. You click on this guy, and then let's, what we call it, the test. I'm interested in the test data. I will upload it here. And then I will go to where it says evaluate, and then I will say prediction, connect this guy to this, and connect this guy to this. So this is my model, right? So now I can see what my logistic regression is predicting for me, that this particular person or the first row will not have heart disease. On the other hand, the second, the third will have heart disease, right? So this is what we mean by future data, right? So, or a test data. So now, if when I have new patients and they have all those characteristics, I can predict whether they will have a heart disease or not. So if they are going to have a heart disease, then we can intervene. We can do something. Maybe we can take them through a diet regime, right? Where they, lose weight or do something before they get the heart disease, right? Even if we predict and they don't have heart disease yet, but we can actually intervene earlier. So that's the beauty of machine learning. So you got the, so that was one thing. Other thing that we have been using also in order to assess the performance. Some they look at the area under curve, which is AUC, area under curve. So let's look if we can see that area under curve. So it's the ROC analysis. So let's see, I believe it's this guy. So the area under curve. So the higher, so this is the status quo. So if we didn't do anything, or the random effectiveness or prediction will be this line. But actually, if our model is doing really well, so this area under the curve, under this curve, the higher, the larger the area, the better our performance of prediction or classification. So that's what we mean by the area under curve. There are some others, but this is enough at least to get the core benefits, or the core function of data mining is to use is what I have covered so far. So this is what you will do for your homework.